Welcome back. This is question 2 of Webwork 6.1, and we have a very similar problem. We just want to determine the radius and interval convergence for the series n factorial times x to the power of n. So slightly different. So we can define our u of n, which is just our series. And then our u of n plus 1, which we're just adding 1 to n. So again, we have that. Now we just got to plug it in. So we have our limit as n approaches infinity of if n plus 1 factorial times x to the power of n plus 1 over our original n factorial to the power times x to the power of n. Simplifying our expression can give us n plus 1 times x to the power of n plus 1 over x to the power of n. And that further simplifies to simply n plus 1 times x. Now, in our problem, we want for x is not equal to 0. So if x is not equal to 0, the limit simplifies to limit as n approaches infinity, absolute value of x times n plus 1. The limit approaches infinity as n goes to infinity for any x except x equals 0. Therefore, the ratio indicates divergence for all x not equal to 0. So now we know that's infinity. And we know from the results that it is only at the value for when x is equal to 0, every term in the series is 0, thus the series converges. So it converges there, but it only converges at that point, which means it does not converge on the interval, but it converges only at that point. And since it does converge at some point 0, that means our radius of convergence is also 0. And that is the solution to question 2.